Okay, it's Saturday, April the 9th, 2016. You're looking at a star that's to the left of Orion, which is just passed by, going on to northwest. I'm looking southwest and more west than south right now, because I had some problems adjusting the stand because it's so cold. It wasn't holding properly. And as the screws get colder, they loosen up and I have to keep moving it. But the star keeps moving as well, and it's moving in a direction different than the Earth's spin, and therefore it seems to be moving faster. Look at all those orbs in the cluster. Okay, you see the cluster all around the star? That's the parent cluster I'm talking about. Okay, it's all around the star and it's humongous. It's thousands of times larger than that star, which is the nucleus and the powerhouse that feeds that cluster the energy so that the orbs in the parent cluster can survive. Okay, so the other thing I wanted to talk about is you can see the large orbs on the outside there, you know, just pumping out. They're actually like just shooting out of that star, because each star is a stargate, and it's here shooting out orbs that come through the stargate itself, or it's shooting out the orbs by processing the larger parent cluster through the nucleus, and as the orbs get charged up or powered up, they have to leave and make room for others that are low on energy. So there's a constant exchange of orbs inside the nucleus itself as the star nucleus, or as the nucleus, which is the star, recharges them or charges them up. So anyway you want to look at it, that nucleus, the star, and I don't know the name of it right now. I'd have to look that up. Boy, it's moving. Okay, I'm going to have to hold this thing on it, and I'm going to move this closer and try and regain where it is. Okay, I got to back up. Okay, there it is. Now I'm really far out. Okay, I'm still 250 extra on it. That's zoom I'm talking about. This is a 250 zoom. Okay, so here I go. Lower this a little bit. Okay, 350. Okay. 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 425. Okay. So at 425 X, you can see. Okay, this star is really far away. At 425X, you can see that the orbs are shooting out from like all different points of the nucleus, but mostly visible from the left and the right side, or in this case tonight, the south and the northwest, or the southeast and the northwest corner or side of the star, which is the nucleus. And you see all those orbs all over in the air, just they're in a counterclockwise motion around the nucleus, and they're at a really high velocity. Usually the outer clusters, or the parent cluster, the orbs move around a lot slower, in a normal sense, or under normal circumstances. The ones closest to the nucleus move faster than the ones on the outside of the nucleus, like farther out. So it depends on their proximity to the nucleus and how fast they revolve. Or they seem to look like they're going faster, but in the long run they're all going at the same rate, because once the frequency, the vibrations frequency and velocity is set, and that also entails the electromagnetic frequency, then they all spin at the same rate. The ones closest to the nucleus just look like they're going faster because they're making a smaller circle around the nucleus, so the circumference is smaller, and they look like they're traveling faster, but in actuality the ones on the outside are going at the same rate. So the rate is the same for all the orbs. It's just that they appear to go slower because of the proximity to the nucleus. The other thing is that even though they're going around in like concentric circles around the nucleus, there's still orbs, if you can see them, going around counterclockwise in their own circles, okay, all around within the entire cluster. So it's like a whole bunch of orbs just moving around in all different directions, but all moving counterclockwise in various circular movement, either around the nucleus or just in the cluster itself. Okay, because this nucleus may not be the only nucleus of this large cluster. On the other side of it could be another nucleus or more than one nucleus. A cluster this size can have multiple nuclei, and therefore this may not be the only one. So this star, could be just a part of a constellation, and the cluster could be the cluster for the entire constellation, not just one star. And that's something I just, realized recently. Okay, so here's what it looks like up closer. I don't know anymore after 425x. I have a long line that just keeps going because I did a lot of work in this camera and I didn't mark this up, so it's now just a line, and I'll approximate at about 550, 575x right now. Okay, so you can see the star at work, or the nucleus at work, and you can really see the orbs in the cluster, how fast and how much they move. Okay, the little shake, maybe it's a big shake when you watch it on the screen. I'm looking at a very small screen right now, but the screen is showing a shake because I'm holding the camera on the star, because it keeps moving. Okay, right now I'm just shaking because it's so cold out, but the star keeps traveling and it's going really fast, and if I don't hold the camera on it, I'll lose it. See what I mean? As soon as I let go a little bit, I lose it. So, okay, I just moved closer. Okay, just want you to see this up even closer. I don't know how many X I'm on now. It's really hard to say. I'm halfway up on my capacity. Okay, now it's really hard to hold the camera. Oops. On it. Okay, I'm not going to go any farther. Closer, because right now I want to show you, like the whole thing at work. Okay, you can see the big orbs on the outer circumference of that really bright white part. Okay, and then you can see the energy, coming off of them, like in red and blue and light blue, and the orbs shooting out. You can actually see them. See how fast they shoot out? That's what's happening on our moon. Our moon hologram, or cluster nucleus, because that's a star too. But it's in a baby stage. It's not as big as this thing. This is a huge star. I'm probably at, I don't know, it's like 600x, and it's, that's still small for this kind of zoom. It's pretty far away and everything. So this is a big star, and you can see that the orbs are very huge too. Now I've taken some still shots and shown large orbs next to it, and even holding on to a star, but that was the star Sirius. But I have other photos from different stars. They all practically adhere to the same kind of situations and same kind of processes, and orbs are always involved, because what makes a star is that orb cluster all around it. Okay, and it's the spin, okay, around the axis of the nucleus, and vibrations frequency and electromagnetic frequencies, and just like all of those orbs in the nucleus being compacted into a tight squeeze by the larger parent cluster that's creating all that energy. And you can see how bright that is, and you can see the large orbs. Okay, those large orbs on the outside of the bright part, they're keeping all that energy in. Okay, but there are large orbs inside and outside of that star, the star, the nucleus itself. Okay, you see that the star is not always round. It constantly changes shape. Hold on. Okay, so it constantly changes shape. It's never, you know, the same. It doesn't shoot the orbs in the same spots. It shoots all over 360 by 360 by 360 because it's a spherical configuration. It's not just a flat circle. So in that nucleus is like a diamond. I've shown that on camera the last time, but that diamond is really a hexahedron, except, you know, on a two-dimensional image on a camera it comes out looking like a diamond, but that's just an impression. It's really a hexahedron. The stars are hexahedron in shape. Everyone I've seen so far in its true form was a hexahedron, and that shape keeps changing, and all this changing of shape on a star is all those arcs being shot out by the orbs between the negative and the positive fields that I keep talking about. They're you know, on our moon hologram. Thing went out of sight. Hold on, I lost it. Sweet. Keeps moving, and it's hard to keep track of it, especially when it's this cold. Okay, I gotta reset the camera. I think I'm about at the same place where I left off. Okay, you can really see the orbs working now. I'm trying not to shake it. I'm still holding the camera because I have to hold it on the star. You can see the orbs. You could see that the nucleus is red hot. I mean white hot. But it's red hot all around it. And the orbs shooting out are leaving a light blue signature. That means they're cooler than the hot white, but hotter than the red. It's like a butane flame. It's pretty hot. Okay, so they're not yellow. They're that blue flame that, you know, is really hot. When you get the right oxygenation, you get the flame working just right. Okay, so that blue is like that. But the white, that's red hot. That's really hot. Okay, and you can see how fast the reactions are taking place and how fast that star is working counterclockwise, and the velocity of the orbs which make it up. Okay. So, all that, my hands are now frozen. I'll try and hold it as steady as I can just for a minute. So you can see that the whole thing is in super fast motion, counterclockwise motion, and that the orbs are shooting out all over from that nucleus, and what it's doing is recycling that cluster from orbs that have lost their charge. It's recharging them and sending them back out and taking new ones in, recharging them and sending them back out, and this just keeps going on and on 24/7 non-stop for as long as that star has the capacity to operate as a nucleus. When it loses that capacity, the star collapses, and then you have a supernova on a star this size. Okay, it collapses under its own gravitational pressure, and it collapses from within, and when all the mass collapses upon itself, then you have a supernova. And in 2009, that's what happened to our moon hologram, but then the parent cluster just reconstituted another nucleus within a matter of seconds, and the moon was back. Okay, right after that big explosion. And my video on that is called The Explosions on the Moon, December 4th, 2009. The explosion actually took place on the 2nd of December, but I didn't put the video on until the 4th. So in those days I used to put the date that I put the video on rather than the date when it happened. But it was December the 2nd that the explosion took place. There was a lot of explosions prior to the major one. On the 1st, I have pictures of that. I have video of that too. It's all in the same video. And then finally the whole thing blew up, and I took a snapshot right as it blew up. And then a blast wave went right through me. I could feel it, and I could feel it going right through me. And then I put another video on the 7th. I put another video out on the 7th of December that year, 2009, and I showed the radiation coming off from that explosion. And that was also just like a few days after I put out the original video. Wow, I'm tired of holding this. Anyway, this is just space. I didn't change the zoom setting. This is the orb cluster, or the parent cluster that's supporting that star. But this is how space is everywhere. Those orbs are just everywhere. They're even in our atmosphere right here on Earth. But these ones that you're looking at now are huge. In our atmosphere, they can be very large, or they go from very large to so small you need an electron microscope. You can't even see them with that. But they range in many sizes. But in space, there's no need for that. So most of them are large, but obviously since they reproduce, there are small ones too, except they're not visible from where I am here on Earth. Obviously I don't have a Hubble telescope. I have the mini Hubble, 5 by 2 inches. Okay, so it's a pretty good camera. I've done a lot of work on it. I'm proud of it. I put a whole lot of effort into it, and it can take video and photos like this from very far away. Let me find that star again. I got it back up, because now the thing has moved a whole lot. Okay, there it is. Here, I'll go all the way back. Let's see if I can see it. Okay. Okay, so it's not visible with the naked eye. Ah. God. Okay, the reason I don't wear gloves is because I can't work the camera with gloves on. Okay, so there's the trees and everything. You can see, you know, like shooting this off my balcony because I wired this up and I did what I said I was going to do. I have a double redundant system here so they don't destroy my camera by shorting out the electricity. This is a camera connected to electricity. Now I have all of them able to do that. Every camera I have, which is like, I don't know, at least half a dozen. So I've been busy on that, you know, because it wasn't really hard to do, just a matter of thinking it out. But I have a double tripper, and I won't have to worry about the thing, you know, blowing my camera up, which they've tried to do. The orbs, I mean, they've tried to blow up my cameras. They've already blown up 3 of them, and it's like war with these things, because they're not that friendly, especially when you figure them out. It's so cold that the stand won't stay where it's supposed to. I don't get it. Like, it's very cold out tonight. Maybe there's just a lot of orbs around me, because that's happened one time when I filmed a video with that wheel within the wheel there, the beings of light video. Man, the temperature dropped like it seemed like 100 degrees. I was afraid of dropping my camera off the balcony that year. That was at the end of 2010. That was like New Year's time, 2010 to 11. The temperature had dropped so low in a matter of seconds. I was scared of dropping my brand new high-definition camera, my very first one, right off the balcony. And I wasn't even at my place. I was at my mom's. And she was way up in the air. If I dropped that camera, there wouldn't have been a piece left. How high up she lived. But I had a good view. Man, this thing moves all over. Okay, I don't know why I'm not able to get the camera to stay. It keeps sinking because the thing is just getting colder and colder, and it's making the screws looser the colder the thing gets. But boy, it got cold in a matter of minutes. Wow. And okay, that was my fault. Okay, I moved the camera. I'm still here. I don't want to talk. Just let the camera do its thing. Okay, every now and then you'll see an orb try to get shot out, or just about to get shot out, and gets pulled back in. Now that's from the momentum of the counterclockwise spin, and also from the electromagnetic field that's in that nucleus. He throws the orbs back in. So in order for them to escape, they have to reach escape velocity. It's like leaving the Earth's atmosphere in a spacecraft. You have to reach escape velocity and break gravity, but they're not breaking gravity, they're breaking centrifugal force and the electromagnetic field that's holding them in that nucleus. So until they get up to speed and the proper velocity, they can't escape the nucleus. Okay, it's only when they reach escape velocity that they get out of the nucleus. But this is all like either a natural thing for them, or it's planned, or they figured and calculated the whole thing out, because they don't leave until they're all charged, fully charged, and they don't come in until they're very near, like probably near death or expiry, should I say, of energy. They're not even allowed in, because there's like a electromagnetic field that's like a membrane, and it's a permeable membrane. It only lets the orbs that need a charge in, and only lets the orbs that are charged up out. And no other orbs get in or out. Okay, so this is like a cycle. And that big orb cluster, I'll have to back up to show it to you. What is wrong with this thing? Almost. Yep. Okay, I gotta back up. I hate backing up. Okay. The whole camera and everything, the stand is so loose. I don't know what happened to it. And I'm shaking like crazy myself. I know what happened to it. It's so cold, you see me shake. You can't even hold the thing steady. Okay. I'm too close for you to see the parent cluster, but now I'm even closer than before. Now you can see that the way the star is, the nucleus is operating. See all those changes, and then the shape shifts. And that's not me, shaking the camera or anything. And that's the nucleus doing that. It's under so much stress. It's holding so much power within itself. You see, it can hardly hold the energy in place, and that's why it's doing that. And that's where you get the different lights when you look at a star and you see like blue, green, red, white, that's where it comes from. The star itself can't hold that energy, or the nucleus can't contain the energy, so it's scrambling to keep it all together, and that's the reason that happens. Whew. Okay, I'm exhausted, but I'm freezing. So I just want to show this parent cluster with the star in it. I don't know if I can do it. Oh yeah, there it is. Okay. And if you can see it. Okay. The thing is huge. Okay. You can see how the star, it's spinning so fast, it's sort of like catching itself. It's spinning faster than the energy, and it's like the energy has to catch up to the momentum of the spin. Okay, and that's what's going on. It's like lagging behind the mass. The mass is lagging behind the velocity of the spin, and then it catches up because it's pulled in by electromagnetism. And man, these guys never stop every time. They just don't give up. Okay, it's pulled in by the electromagnetism, and it's also pulled in by the spin around the axis of the star. Okay, the centrifugal force. So as the energy tries to, or the energy mass is trying to catch up to the momentum, it has a lag. Okay, it's like jet lag. So that's why the star looks like that, and that's why you see different colors and, you know, double images, and it's not your imagination. That's really the way it is. And this is just a small, you know, this is not like right up to it where the shaking would make any difference. That's the way it is. Okay, you're seeing the way the things are when you see that. And the colors, that's also the way things are. There are different colors. It's not your imagination. Okay, again, this is April the 9th. Must be like 11:30 p.m. by now, or at least 11. I started at 10, so no. Yeah, I started about 10 after 10 because I had problems in the beginning, just trying to set it up. So it must be close to 11, and this is the video for tonight. And I just wanted to show you how the star works and what a star is. And the main thing I want to tell you is that our moon, you know, the Earth's moon, is just like that. It's a star, but it's a star in its early stages. And boy, it's a real bummer that it's so close to us, because when that thing, it's already started to get larger and more powerful, and its electromagnetic field is getting stronger. When that thing starts to affect the Earth, especially the core of the Earth, that electromagnetic field, when it starts to affect the core of the Earth, it's going to be bad. So before we're in serious trouble and there's no more human race, we got to start looking for another, you know, another planet. And I'm not joking, because our moon okay, is a orb cluster nucleus, and is a star, just like this one. Okay, it's absolutely no different than this one, or any other star for that matter. Okay, because that's what it is. It's a star. It's probably been around longer than the Earth, but it takes billions of years to make a star, much longer than a planet. So, I don't know how much time we have, but you know, things start to move faster and faster the larger it gets. And you know, we could have some time left, maybe a long time left, or you know, maybe just a short time. I don't think we should wait around and find out how much time and and squabble about how much time we have. We should start working on building something that can go out there and find a suitable planet that we can all move to, or at least part of the civilization move to, so that we can save the human race from extinction, or we'll wind up being just like the dinosaurs. You can see the flashes as the orbs leave, and that's usually where I take my photos of, is just a few that leave, because I have to shoot them from a distance like this, because if I get too close to the star, especially in still photos, the star is too bright and it just drowns out the little lights. Oh, I can't hold it anymore. That's it. Okay, thanks for viewing. Have a good night. This is Super Mushmouse. Thank you.